Now, there's a lot of things going on in the world. There's chaos there. There's opportunity there. I hear there are ladders, but there's one question that's always on the top of my mind.
Do you like turtles?
Yes, Professor Wolfram. This is an extremely important fact. Why is this?
The world exists on the top of a giant turtle.
Thank you. We've been arguing about this for years. How exactly would it work? Is that the precise metaphor? All I know is I ask questions. Questions can be dangerous. Here's the intro.
Though I know I should be wary, still I venture someplace scary. Ghostly haunting, I turn loose. Beetlejuice! Beetlejuice! Beetlejuice!
Hey guys, what's going on? Memes here. So, the reason I bring this up, because very often we talk about different things that might make up the universe, such as the fine structure constant, which a person on the internet happened to let Mr. Thad Roberts know that there was a discussion going on. They happen to have this equation that was very close. And then Thad cleaned it up. And he's like, let me assume this is right. What would I have to do this? And that was simply basically subtract out the Planck mass. And the actual answer is technically 1 over x plus x cubed over 2 pi. That's the hyperbolic twist there. Well, that's how it works. I want to derive the Planck mass by myself, but I actually need to sit down and read the whole thing. Rather than just jumping around to do the equations, this is one of those things you really kind of have to learn. But when you start having things like that, or basically the golden ratio or whatever, basically the fine structure constant, that's the thing that's 1 over 137, or 137.02, whatever. Why do I say this? Because apparently there are actually scholarly studies working on the symmetry of turtles and tortoises. It was biologically incorrect there. I apologize. I'm not a biologist. But as we can see here, abstract, the squigs at modic, phyllodesis, and the turtle shells characterized by 2 phenomena. Phylogenetic stability of the general body plan and wide individual variability. The study of turtle morphogenesis allowed this phenomenon to be explained. It is shown that skewed rudiments are formed in embryonic as its local epidermal thickening plastodes. The positions of the plastodes is strictly confined to certain parts of the body, and their foundation is realized in a strict sequence. I assume that's the shell part. In particular, in the carapace, the plastodes are formed exclusively opposite the transverse trunk mesopta and the septal depressions of the embryonic integument. At the same time, marginal plastodes are formed in each septal depression, i.e. segment by segment. Plastodes of pleural and central series are formed in alternate position in the even and odd depressions, respectively. The stability of the shoot pattern is connected with the basic mechanisms of morphogenesis. Morphogenesis, you say? I love the Power Rangers. Providing the maintenance of bilateral symmetry and determination of shoot positions by the primary embryonic segmentation. The main source for phloidosis that I butchered, variability is the presence in turtle embryos of vacant septal depressions in which the extraordinary plastodes could have developed in the case of minor disturbances of embryogenesis. Want to take care of your kiddos while they're in the oven. These aberrations are rather frequent and usually result of asymmetry of the situation. It's talking metaphorically. Do not put children in ovens. Even if you're a witch, you don't get a pass. The breaking of turtle phylogenesis of symmetry is connected with deviations in ontogenesis, such as asymmetric formation of epidermal plastodes with a shift to one body side segment or more, the formation of additional plastodes in the vacant septal depressions, atypical fusions of neighboring epidermal plastodes, and the ambience of regular epidermal plasmids in typical body segments. Now that we've driven everyone away, we're actually just going to look at the pictures, just because I started reading. Oh, they're actually measuring some turtle shells. There's actually some studies on this. They're actually publishing things. Doing the markings down. They're combining the different shells. Oh, look at that symmetry. Wait a second. Those aren't vortices. Would you say almost forming in a turtle shell? I have no idea. Oh, little baby turtle. So cute. Showing the different shells there. Okay. We go over here. This is Shoutout. Generic green skills for creativity and innovation. Tessellation of regular polygons. Why do I show this? Replicating shapes. Reptiles. So they're tiling the plane. I actually remember this in Wolfram streams when doing dominoes, and apparently once you get to a pentagram or a hexagram, it started getting very interesting. Just saying. I'm just saying. Okay, look at the little symmetries there. Oh, it's spinning in on itself. That's fascinating. You can do it in triangular. Oh, look. 2 triangles. I suppose if you turn a tetrahedron into a 2-dimensional figure, it might look a little like that. Some more patterns. Pretty shapes. Okay, and again, that's just an exercise. Now, not to connect this to anything else, but the Eddington-Finkelstein coordinates. What is this? In general relativity, Eddington-Finkelstein coordinates are a pair of coordinate systems for Schwarzschild geometry. Example, spherically symmetric black hole, which are adapted to radial null geodesics. Null geodesics are the world lines of photons. That's light. Radial ones are those that are moving directly towards or away from central mass. Again, this is Wikipedia. They are named for Arthur Stanley Eddington and David Finkelstein, although they appear to have inspired the idea. Neither ever wrote down these coordinates or the metric in these coordinates. Roger Penrose seems to have been the first to write down the null form, but credits it to the above paper by Finkelstein and his Adams Prize essay later that year to Eddington and Finkelstein. What a nice guy. Most influentially, Miser, Thorne, Wheeler, in their book Gravitation, refer to the null coordinates by that name. In these coordinate systems, outward and inward traveling radial light rays, which each follow a null geodesic, define the surfaces of constant time. Well, the radial coordinate is the usual area coordinate, so the surfaces of rotation symmetry have an area of 4 pi r squared. That's how you figure out a sphere, to my recollection. I am not a logician nor mathematician. One advantage of this coordinate system is that it shows the apparent singularity at the Schwarzschild radius. It is only a coordinate singularity and is not a true physical singularity. While this fact was recognized by Finkelstein, it was not recognized nor at least commented on by Eddington, whose primary purpose was to compare and contrast the spherical symmetry solutions in Whitehead's theory of gravitation and Einstein's version of the theory of relativity. Why did I say any of that? Oh, look. The tortoise coordinate. Now, again, I realize it's not biologically correct, but Eddington-Finkelstein coordinates are found upon the tortoise coordinate, a name that comes from one of Zeno of Ilias' paradoxes on an imaginary foot race between a swift-footed Achilles and a tortoise. The tortoise coordinate R is defined as, what is that? It's R apostrophe and little star equals R plus 2GM. And that's, is that the linear? Is that the log? Oh my God, I need to learn math. Bracketed R over 2GM minus 1. So as to satisfy D of R over there over D of R 1, 2 GM over R to the -1. The tortoise coordinate R. Oh, it's the turtle. R of turtle. The R of turtle. It's supposed to be a turtle shell. I see what you did there. Well played. Approaches infinity. R approaches the Schwarzschild radius at 2 GM. When such probe or such light ray or an observer approaches a hole in an event horizon, its Schwarzschild time coordinate grows infinite. The outgoing null rays of this coordinate system have an infinite charge in T traveling out from the horizon. The tortoise coordinate is intended to grow infinite at the appropriate rate, such as to cancel out this singular behavior coordinate systems constructed from it. The increase in the time coordinate to infinity as one approaches the event horizon is why information can never be received from any probe that is sent through such an event horizon, despite the fact that the probe itself can nonetheless travel past the horizon. It is also why the space-time metric of the black hole, when expressed in Schwarzschild's coordinates, becomes singular at the horizon, thereby fails to fully chart the trajectory of an infalling probe. Now, again, I'm just saying that if we figure out the fundamental of essentially whatever's in front of us, whether it's a turtle, you, me, or anything, if you actually know what's actually going on, then I don't know. Couldn't you actually basically predict the rest of the universe? Now, I'm not saying that something like that might look a little bit like a black hole. And if you technically focus, giving the flow that it goes in and out, kind of goes on forever. Is that infinity? Might that explain why we've been having such trouble explaining the affinities in physics? I'm just saying, hey, peace out, everybody. Thank you all for watching. And just remember.
It's turtles all the way down. You know,
Right.
turtles all the way down.
Unfortunately,
I lose that meme. I don't know what that meme is about.
I apologize. Peace out, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude.